Okay, I just want to show you again this terrible disruption across HF that a number of people in the past have said to me, oh yeah, it's just solar interference, yada yada yada, which of course it's not, because I've monitored and see it in the middle of the night too, where solar doesn't work. What I want to show you, right, so obviously you can see these, especially on the left there, notice the red horizontal pulses. Now they are actually going across all the way to 30 megahertz, but of course the receiving antenna has points where it's more and less sensitive. Now I want to come down here and zoom in and show you something, right? I'll just zoom out a bit. Let's have a look. So where are we now? We're in the AM broadcast band, right? See? And see where it starts. Okay. Just about at the start of the amateur band. So yeah, so just from, so most of the AM broadcast band is spared. You see this? But this pulsing is so rapid. Look at the S meter. Now I'll go into where it's strong. Look at the S meter. It's not showing much, right? It's deceiving the system. But it's so rapid, it kills the HF band, right? And this is not just local to this particular receiver. Now I'll show you what I mean about it going across more of the spectrum. So now we're looking across the whole spectrum, right? So up here, for example, it doesn't look so severe, okay? So I'll come into that section and I'll just adjust the waterfall because of the lack of sensitivity on that antenna. Let's try and get this to in the right parameters to show this. I might have to zoom out a bit. Yeah, you can see, hopefully you can tell, yeah, there's all these rapid pulses going across, okay? Now, it might not be as noticeable here, but it is there, right across, alright? Now, of course, if you just zoom into a part where you were operating, you don't realize the S meter is looking low. You just don't realize there's this super complex, rapid, terrible disruption going on across HF, and it appears to be a highly intelligible signal. So let's see, let's come back down. I'll try and show what I mean if I can. If you watch it for long enough and look at it from different perspectives, you start to see that there's actual sequences. It's not just pulses and noise, that there's actual some sort of control to it. Which is, let's see, I'll zoom out. Sometimes you get to see, like, you can actually notice particular patterns and things. So that's one particular SDR, right? Let's jump out of there. If it was solar near that site or whatever, then perhaps we wouldn't be getting it down at, that was one of these ones up here. So let's try this one at Ironstone Range. And I'll back out, or actually back out all the way again. And I'll adjust my waterfall. You can see the pulses. Some of them are going to be picking it up more than others, but it's there, see? And it's a real killer, but the S meter is showing low. Alright, I'll now jump to another SDR in a different spot. Okay, let's say down here in, I don't know where that was, I didn't take a look, but right, I can hear it, I can tell because I'm so used to it. You can see the pulses again, especially if you notice across to the left. So I'll adjust the waterfall so that it's more obvious. Right, and I'll zoom in now. I might have to make another adjustment there. There it is. And it's right across from roughly 1.8. You can hear it up here, down to from about 1.8 megahertz up to 30 megahertz. But of course, a lot of these antennas are probably less sensitive up there. But I'll change the waterfall to try to compensate for that, and we'll look up at the higher end. And you can hear it anyway, right? So that's up at 26 megs. 28. And sometimes I'm monitoring, and then all of a sudden it just switches off, and suddenly a nice clear blue background comes up. Alright, so alright, I'll zoom out fully, and what I'll do is I'll just go in like a normal person would, certain frequency, auto scale, and zoom in. Auto. Okay, I might have to do this one. Well, this one's actually copying it quite badly. Okay, this one's really getting it bad. So, all right. Where else to go? Let's jump down here into actual Melbourne, my neck of the woods, and I'll zoom out all the way. And alright, let's adjust this. Oops. And it is across the whole spectrum, and it's extremely rapid. Well, the whole HF spectrum. So I'll now jump to oh, sorry me. Let's go auto. So now I'm in the AM broadcast band. And of course, you can see the carriers from the stations. Alright. And hang on, let's get this to. Where are we here? The noise seems to start around this area. There, yeah. So basically, around 1.7, 1.8 megahertz upwards is where the noise really starts to kick in. Adjust the waterfall to highlight it. But it, you know, you could be forgiven for not realizing it's there and just think, oh, the band's terrible. Right, but 7191, like I'm transmitting on that frequency right now locally, probably not great conditions anyway for locally. So what I'll do, just to show, I'll show a couple more things. I'll jump back up. These are really good ones up here in VK5. Well, I think they're apparently using the same antenna on both. So let's go 7191. Right, so I can hear my beacon there now. Okay. Now, what I want to show is the, let's have a look at the conditions, right? So I'll just reload and get this hourly HAP chart data up. So from my location, well, we got the, to let's say VK5, it's not ideal, but it shouldn't be terrible. We've got the two different greens there for the area I'm targeting, which is 8 to 10 megahertz, right? I should be making that trip at the moment, but I'm not. And the brown, as you see there, 6 megahertz, I should be making that trip into that particular area. Now what I'll do is I'll take another look, SWS ionospheric map, Australasia. So now we'll look at the NVIS, okay, and the my region and the receive station in South Australia there is good for 7 megahertz. Okay, so it's not that the band conditions are shocking. One sec, SWS ionospheric map, can't type sometimes. Global. And, alright. So across the bottom of Australia, NVIS refraction is good for 7 megahertz. Yet the band appears absolutely crap. And it's because of whatever this system is. I think it's some sort of military operation, could even be weather mods, and no, you don't need to wear tinfoil hats to talk about that, because China quite literally have bragged about their increased capabilities with weather modification and how they can now influence the weather in an area larger than India, which makes me wonder which area they're talking about that begins with A. Down under. 7-3, and thanks for watching.